Hello everyone, I'm Ms. Gian and today we're diving into chapter 5, which is reliability. So we've covered this one very briefly in the previous slides already. For the next 3 chapters, we will do a deep dive on these constructs, right? Reliability, validity, and then test utility. So again, this is a foundational concept in psych assessment because you'll be coming back and encountering reliability all throughout your career in psychology. So kung ang validity ni ingon or ni kuan na ato ba gyud na measure ang atong dapat i-measure. So mo nang mermaid atong kuan dili no kay the mermaid represents the true score. Did we really capture the mermaid or the true score, or are the errors more mas daghan tang nakuha na error compared to the true score compared to the mermaid? Okay? So pero reliability as can we trust our measurements to be consistent? So we're now looking very closely to the shrimps, to the errors. Now, we will talk more about them in the next few slides. But before that, let's look at the learning objectives for this session. So our learning objectives for this session is that I want you to walk away being able to do 5 of these things. So first, define what reliability actually means and how it connects to true score theory. Okay, so more on that on the true score theory, no, you will understand what that theory is. But I feel like you already have an idea because I've been mentioning it in the previous lectures. And then number 2 is identify and describe major sources of error variance in psychological testing. That's why I told you that we'll look closely sa mga shrimps, sa mga error, okay? And the next, differentiate between types of reliability estimates. We have the test retest, alternate forms, split half, and internal consistency. And then number 4 is interpret reliability coefficients and the standard error of measurement in practical contexts. And of course, number 5 is to apply all these to evaluate whether a psychological test is actually of any good or it's of good quality. So let's start. So unsa din ang reliability? We've covered this one already, right? Simply put, it's consistency, okay? That's the word. It's consistency. So if a test is reliable, it gives you similar results under similar conditions. So example ani ang ruler na analogy, right? We have here 2 ruler. So natay ruler made of steel and then kani kay earthworm na lang akong gibutang no, but example natay ruler made of guma, okay? So usay English sa guma, rubber or but that kana siya guma. So duha atong ruler. Now, ang kani siyang ruler, it measures kay made of steel man siya. It measures the same thing the same way every time. So kung ang 12 inches today, inig-measure nimo again 12 inches na pud tomorrow. And then inig-measure nimo inig afternoon 12 inches gihapon niyang makuha. Okay? So example, nag-measure kag shoes gamit ani na ruler. 5 inches imong nakuha ron. Ugma 5 inches na pud. The next day 5 inches gihapon. So mana siya every time the same thing, the same number ang makuha. Meaning ana high iyang reliability. Okay? But imagine a ruler na made of guma. So di ba kanang guma kung init mura man siya mugamay. So dependent kayo siya sa weather conditions. So kaning guma ma-stretch siya, ma-bend siya. Kanang guma class mo gamay ba mo constrict or mulanay so marag ma-stretch out siya, basta you get the idea, right? So if you measure the guma na made of na ruler sa 5 inches na shoes, today you probably will get 4. Tomorrow you'll get 10 inches. The next morning you'll get 2 or 3 and etc. No, so dili siya kakuha consistently. So unsa man ato ang lesson for that, no, when we're talking about reliability. So reliability is about the amount of error in our measurements. Let me repeat that. Reliability is about the amount of error in our measurements. Okay, we're looking at the shrimps, dili sa mermaid, okay? So meaning, kung gamay atong error, mas dako ang ato ang reliability. Okay? And how do we express this? We express this as a coefficient ranging from 0 to 1, where ang 1 means perfect reliability. Walay error at all ang measurement, which is, well, in an imaginary world could be possible, but we live in a reality and we've already established that error will always be part of measurement. So at some form, dili gyud na siya mahitabo na makakuha tag perfect reliability, but we aim to be as close to 1 as possible. Okay? Now, sa psychometrics, ang moingon tag reliability, di ba man tag reliable ang person is someone you can depend on. It's someone that's consistent, right? If you're looking for a good character sa partner, mana kag I want that person to be consistent, di ba? Pero sa psychometrics, ang reliability, it doesn't mean na nindot. Kay if the error is in the measuring tool, then you might be consistent, but you are consistently wrong. So imagine if kaning ruler, pagkagamaan niya, wrong ang nabutang na mga numbers here. So even if 12 siya every time, error siya kay what if ang iyang gi-measure, iyang actual measurement di ay ato na sapatos is 10 inches, but every time sige na siya ka-measure og 12. Okay, this was already natagad na ning example katong different types of scales, right? So consistency doesn't always mean it's good. It just means that it produces the same number every time. So let's get into the theory behind all this, and that is the classical true score theory. Now, when we say classical true score theory, nana siya assumption, and this assumption can be seen through the form of a formula. So, unsa ang formula sa true score theory? Formula niya is x equals t plus e. Unsa na siya? So, x is our observed score, and then t is our true score, and then e is the error. So, if we look at it sa ato ang analogy of the mermaid and the shrimp, now ang observed score, so when you get a test, example, reading ability test or intelligence test, that is the observed score. It is a mixture of the true score, meaning iyang actual ability to read or iyang actual intelligence, and an error. Okay, so it could be measurement error, it could be systematic error, meaning ang error is naa sa imuhang tool gyud, or it could be random error. For example, when you were taking your exam, katong saba kayo nag-construct, the noise level, that is an example of error in measuring or measurement. Okay, so ang true score, if we remove the error, okay, so that is the true score. Now, without the shrimp, mo na siya ang kanang true score without the error. So meaning we're capturing the mermaid alone. But we can never actually know someone's true score because again, kaning mermaid, di ba? Sige, tagamit mermaid. Dili siya makita, no? So we can only estimate the mermaid. We can only estimate the value of our true score. Mao gyud na siya ang pinaka key insight when we're remembering or when we're talking about capturing or measuring a certain construct. Okay, so now let's look at the variance breakdown. So we can break it into two parts, kaning variance. We have the true variance and we have the error variance. So unsa na siyang true variance? True variance reflects our real differences. So this is stable in a sense. So example, si person A has bigger intelligence score compared to person B. So in a sense, there are real difference between the two. So that is the true variance. Now, the error variance is an unwanted noise. Okay, so unsa na siyang example sa error variance? Could be si person A is, what do you call this? Is studying at a very quiet na room, and then si person B is studying at kanang naghilak na bata, no, or walay tarong na kuano. Again, that is the error variance. No, it's a noise in the measurement. So you're not actually measuring the true difference nilang duha. Sagol siya sa kanang errors in measurement. And then, naputay gitawag na another form of error aside from, di ba, usually the error variance is unstable na siya. So example, there is a section na nag-quiz wherein noisy kaayo. Naapoy section na nag-quiz wherein nindot kaayong environment, no, walay sabat, tapos naapoy joy whiteboard. Okay, so unstable man ni siya ang kuan. So what you're capturing is the unstable na error variance. Naputay gitawag na stable na error variance, or what you call a systematic error. So, saan ang systematic error? Systematic error is error sa measuring tool jud mismo. So, meaning, katong ruler nato before na analogy, meaning naa siya error sa ruler mismo, dili sa kanang environment, sa conditions, sa test taker, no, naa siya sa measuring tool na error mismo. So, stable ni siya na error, ang kaning systematic error. How do we make sense of all these if we are talking about reliability? So we're still talking about variance and error and true score and observed score. How do we make sense of the relationship between this and this to reliability? So reliability is higher if the true variance is higher. So kindly look at this equation here. Remember, if you're capturing the true variance, so mas dako imuhang true variance na na-capture compared to the error that you captured, mas dako ka og reliability. So panalitan ta lang kaning sa mermaid analogy nato. If daghan kag mermaid na na-capture compared sa shrimps, so meaning mas dako ang imong na-capture, mas makaingon ka na ang observed score is not really precise, close to the precise score of its true abilities. So balik ko na ko ha, kung dako ang imong nakuha na true variance, meaning nakakuha jud kag real differences in score, daghan kag mermaid, so usa ni ka mermaid diri, and then usa pud ni ka mermaid diri. So meaning ana, mas dako ang makaingon ka na imong nakuha na observed score is a close approximation to that person's true score. So hope I'm making sense. Reliability coefficient then is simply the proportion of total variance that is the true variance. Okay, so again, the more high or the bigger your true variance is, the higher your reliability coefficient is. Before we move on to the next slide, I want you to remember that we can never know the exact true score. We just can't. Okay, we can only estimate how much of the observed score reflects true ability versus the error. So I have here a food for thought for all of you, for you to digest what we just talked about. Okay, so think about your most recent exam. So, di ba namoy score? Pero, kana na score, is it a perfect reflection of what you actually know? So, unsa man ang mga factors na that you observe might have caused the deviation sa inyong scores. So I want you to consider the noise level. Okay? So na dito section na nag-answer og very noisy na environment. And I want you to consider luck with questions. Na ko student na dunggan nako na wala siya nagtuon pero nakapasa, right? So possibly that person is just lucky, especially with multiple choice because it's probability. You have over 25% probability that you get the correct answer even without studying. And also the fatigue level. Right? Did you study before or weren't you able to study because you were tired? The test taker source of error ni siya. So I want you to take a minute, maybe write your answer, talk to yourself about this question. Then we can move on to the sources of error variance. So speaking of error, error variance, it comes from three main sources. So sa book, right, we have test administration, test scoring, and then other sources of error. And here I'm showing you three things. We have test construction, test administration, and also scoring. So let's go first with test construction. In test construction, example, maybe some items were confusing or ang sampling sa questions didn't really represent the content fully well. So, example, ang item sa quiz, nakabantay mo na mas dagan lagi naa sa chapter 3, almost 30 items compared sa chapter 4, wala kaayo na discuss, di ba? So, that is an example of test construction na source of error, ang iyang item mismo. And then second is ang test administration. So, unsa man yung example sa test administration, we have mga environmental sources of error. We also have the kanang test taker related na mga variables under the test administration, and we also have kanang another source of error is the one that's administering the test or examiner related na variables. Okay, so example, maybe the room was too noisy. You guys know this too well. Maybe daghan nag-agi-agi, no? Kaya nag-answer sa stairs or nag-construction, saba kaayo. Or sa pa na din dim ba ang light? Like dili siya hayag. So that is an example of environmental or room conditions na sources of error. And for the examiner, panalitan sa examiner variable, basig ang examiner kay dili confusing iyang instructions or kanang ingana no. And then sa test taker, what if gikapoy mo ana na day or naamoy sakit no, and you were taking the test. That is an example of an error caused by under test administration. Then lastly, we have the scoring errors, okay? So usually this is very common for subjective type of test na mas kailangan siya kanang bitawng input sa scorer. So example ani mga essay type of kanang test, mga kanang projective test, no? Kanang kuan siya more on unlike kanang objective measures ba na kanang naagid siya scoring system kani kay magdepende siya sa interpretation sa scorer. So example sa essays palang no, two teachers might give different grades to the same answers a student. Okay, so two psychologists might interpret that sort of behavior or that severity sa anxiety very differently. So that is another kanang differences in interpretation is another form of error. So ang kaning different types of reliability estimates, they're designed to detect different sources of error. So we will be talking about the different types of reliability estimates on the next slide. So our first method is very simple to understand. No, it's test, retest. From the word palang test, retest, reliability. So unsa ni siya? You give the same test to the same people at two different times. And then after that, i-correlate dayon ang score ani niya sa score ani niya. Mora gyud na ang meaning ani niya. For example, we have here a scale. Mahal mo ba siya test? Okay? So you let a group of people answer this for time 1. Then after a few weeks, nilabay, mga 1 week, di ba 1 week, nilabay, ni-answer na pud sila, no? Mahal mo ba siya test? So ang score ani niya, sa tanang ni-answer, i-correlate sa score ani niya. So asa ni siya na form gamiton? First is if you are trying to measure a stable trait and you want to see if the time element is not a confounding factor. So this is great for stable traits. For example, mahal mo ba siya scale measures your affection or love for another person. Hopefully stable ra ang paghinigugma, no? Pag love, no? The love scale, it's presumed to be stable. IQ is presumed to be stable. Personality is presumed to be stable. So this test tries to measure that na after a certain time elapse, will you still earn or will you still get the same score? So if you're measuring IQ here and then after a certain time, example lang ni ha, example imong score here 50 over 100 sa IQ. Example ra ang numbers. Pag next after 2 days ni answer na pug kabalik, imuhang score na himo na dayong 85. So possibly dili ang imong na measure dili IQ but rather memory. Okay? So ang problem ani na test manggod ay ani na form of reliability is that na ay chance for practice effects no or memory. So because I already know the items to the test, that means my score will inflate. Okay? And if there are traits or states that will change, this is not good. This is not a good type of kanang. So ang tawag ani niya is coefficient of stability. This is not good for kanang traits or measurement tools that attempts to measure mga unstable na traits like mood changes or etc. So next we have the alternate forms of reliability. You might notice that in the book, there is the parallel forms of reliability. More on that later. But first, let's define what is alternate forms of reliability. So this method or estimate avoids the problem of memory contaminating the data. So meaning wala nitong practice effects or memory. So what happens here is you have two different forms attempting to measure the same construct and then correlating the two forms. Okay, so there's two versions of the same test measuring the same construct. Now, what's the difference between parallel and alternate forms? Okay, so parallel means that the two tests are equal in means and variances. So, example, if you have two different versions of the quiz, panalitan sa quiz nato, right? Natay version A, test A, and test B. Ang duha ka forms sa quiz, pareha silag numbers, 30 items, pareha silag type of questions, gi-rephrase lang siya. Or gi-shuffle baron ang multiple choice, meaning gi-shuffle ang A, B, ug C. Okay, so technically, the same regular siya, no? The same regular siya, mo yield siya og similar scores if the test is reliable. On the other hand, ang alternate forms is different versions gyud. So panalitan katong example nato duha ka forms sa quiz nato. We have quiz A and quiz B, different siya item sample. So kung unsay sulod sa quiz A na items, lahi pud ang sulod sa quiz B na items. But still, they are measuring the same thing, and that is your learning with chapters 3 and 4 or ko ano similar construct. So unsay advantage ani no, it minimize memory practice effects. You can test again immediately and it's useful for retesting situations. Disadvantage is it's expensive, time consuming, and we can't really create a truly equivalent na two types of tests measuring the same construct. So ang next few methods in estimating reliability will contain some form of formula. So ingnan na lang tamudaan, do not bother with calculating it because if BS math pa mo, or this is like your core ano, I would let you compute it. So since we already have the tools, we have the kanang SPSS or PPSP to calculate for us. You don't need to calculate this manually. It's just important to understand the concept, the theory behind it, what it's used for. Kaya para you understand kaning Spearman-Brown formula, when you encounter it in the test manual or in the journal articles, you would understand what it's used for or say a purpose there. Okay? So the split half reliability solves the problem of kanang the previous two tests wherein it's costly economically in terms of time and money because you have to administer it twice to different groups of people. Imagine if this is a process of you're developing a test and you're establishing its reliability, then it would be costly to test developers, right? If you're doing it twice, you're developing two tests, or you're looking at alternate forms of reliability. So you get the point, right? So that's the solution that split half offers because it only requires one test administration. So unsaon day ni siya unsay steps sa split half. Ang first is imong i-divide ang one test into equivalent halves. So for example, ang katong example nato sa ato ang quiz, panalitan natin 40 items. I-divide na ang items into two. Now, there are various methods in dividing it and some of the methods are not good to do. Okay, for example, if katong test imo siyang gi-divide sa first 20 and then the next is 21 to 40, it could be yung reliability coefficient niya is kanang unsay tawag ani? Kalimot ko sa term, kuan kana siyang influenced by some sort of fatigue. So you cannot really be sure na imong nakuha gyud is ang reliability coefficient because probably on the second half the person or the test taker is already tired. So you wouldn't be able to get no the kuan no, as clear estimate as possible. So unsa may gi-recommend in sa pag-split sa kanang test? First is the odd even split. Okay, or you could do the random assignment. So for example, magbutang mo sa tanang items in a fishbowl and then imong ikuha ang kung ano ang kanang paper naka okay first half second half okay kani siyang na item turn ana so random assignment gud siya. So you can also do this electronically or you can match it by content. So for example, the test 1 to 1, 3, and 5 will test your ability in statistics or is an item for statistics, and then 2, 8, 7, 10, whatever is an item to test out if you know the assumptions of testing. Okay, nga na siya no. So imo siyang i-match by content or difficulty. And then after dividing it into two halves, you can then calculate ang duha ka halves using Pearson R. And then step 3 is adjust the Pearson R using Spearman-Brown formula. Now, why do we adjust the value? Because reliability increases with test length. Now, half test gives underestimated reliability. So, kani siyang Spearman-Brown formula, usually gigamit ni siya to estimate reliability, to get the reliability estimate for shortened test. Example na kay short version sa katong butang talanghana na personality test na 120 items. 'Di ba? So, of course, if ikaw ang mag-answer ana, di na gyud nimo tarungon ang the end of the items or the last few items. So some scholars or researchers would shorten a survey to, for example, 120 items, ilang gamyon to 8 items perhaps, or shorter than 120 would be 60 items, okay, to improve and lessen the fatigue that the test takers experience. So what they is they would use the Spearman-Brown formula to do the estimate or to get the estimate. But again, do not obsess over the formula and whatnot. Important lang yun that you understand what it is used for. Why do we use Spearman-Brown, right? So, unsa ning internal consistency, especially coefficient alpha or the Cronbach alpha, you will encounter this again and again. Okay? So, start ta sa unsa iyang i-measure no, the degree to which all items measure the same construct or test homogeneity. So, unsay meaning ana if homogeneous imuhang test, meaning all items points or reports a number na they're measuring one thing. Okay? So, kung makakita kag di ba sa research, igtanon mo sa instrument. I don't know if you've already encountered a research paper. Tanon niyo sa research instrument section. Naibutang dito, this test has a Cronbach alpha of 0.85, which indicates that the items or the test has high internal consistency, blah. So that just means to say na, oh, our test that we use is reliable for our population after, or our sample after we have conducted pilot testing. So mo na siya ang gamit kasagaran sa coefficient alpha. There's another one, the Kuder-Richardson 20, to which Cronbach alpha is derived from. So the Kuder-Richardson or the KR20 has a lot of versions. It has KR19, 2021, daghan kay na siya versions. Pero what this test is used for dichotomous items only. So for example, sa test items na if you wanna check the kung ano, example kung na ay right or wrong, yes or no, did this person got the correct answer or did this person did not get the correct answer. So mo na gamit sa Kuder-Richardson. Now, unsa man pag-interpret going back to Cronbach alpha or coefficient alpha, this is the preferred statistic because it's used for almost everything. Ang KR20 mangged. Ang KR20 is again for dichotomous items only. Ang kani siya diri nimo makita ang Likert scale, unsa pa na mga rating scales, no, rate 1 to 10 or 1 to 5 on how much you agree with the statements kana. So mo na siyang kanang use o sani kanang preferred statistic ni siya. Now, how do we interpret Cronbach alpha? So generally it's excellent if ang values kay kani 0.90 and until 0.79. If it's lower than 0.70, you would then question whether that item even measures that construct. So for example, item 1, 0.80, item 2, 0.89, then item 3, 0.68. So what the psychometricians or researchers do is they remove that item because possibly that item did not measure, say for example, the variable or the construct did not measure personality, did not measure IQ, did not measure playfulness, or etc. So we need to be cautious also if we have very high Cronbach alpha or kanang coefficient alpha because chances are that item might be redundant in a sense na it kana bitang too homogeneous in fact na it's just measuring the same thing with the other items. So wala na siya naka-differentiate na noon. So be cautious lang. Pero for important decisions, for high stakes decisions, you want these values no 0.90 or higher. Now, I think I failed to discuss what heterogeneous means. So it just means that you're measuring multiple traits. So for example, personality, uh, in a personality scale, or say example social intelligence something in intelligence scale, if your IQ is measuring various intelligence anchoring onto Howard Gardner ba to siya katong seven to multiple intelligences, and then so you are measuring a lot of traits, no, you're measuring your arithmetic ability, your interpersonal ability, your natural ability or intelligence. So if you're gonna input a test anchored on Gardner's theory of intelligence, it might yield low internal consistency because it's measuring different things in a single test. So let's proceed to probably the simplest of all methods, which is also my favorite because again, sa yun ka siya i-understand. Interscorer reliability. So it's also called interrater, judge, or observer reliability. When do we use this method? So we use this method whenever some form of subjectivity is into play. So when humans are doing the scoring. So example there, no, sa textbook if you've read it, na there was an essay that was asked, wherein teachers were asked to grade it, and the score ranged from 50 to 98. So imagine that is taas dako kay siya kanang kung ano gap or range on a 100-point scale. So it's just the same essay, pero you know that if you have that range when scoring, there is a problem with the scoring system because varied kaayo ilahang scores na gihatag for a single and the same test by the same person. So we still see this today with essay test, mga behavioral observations as well, mga clinical interviews, mga performance assessments, and of course projective tests, right? Anytime that there's subjectivity laced or baked into it, anytime that there's subjectivity baked into it, you need to check whether different scorers agree. So I'll give you another example. So imagine You're conducting a psychological assessment where multiple raters need to evaluate the same set of interview recordings. Okay, so for instance, you have these raters. So imagine lang ni silang Sofia Vergara na kanang psychologist ni sila ha. So imagine they're psychologists and they're rating the severity of a person's anxiety symptoms. Or rather, in a group of patients, they're rating their severity symptoms. Okay? And so, kani siya na psychologist na siya 6 out of 10. Kani 5 out of 10, 5 out of 10, 5 out of 10. Right? So, to ensure we have inter-rater reliability, the psychologist then would rate the same recordings without talking to each other, without discussing. So they would just independently rate. And then once both sets of ratings are complete, you then compare the results. And then usually when you're comparing results, it's with the help of a statistics, no, with the help of statistics like or statistical measures like Cohen's kappa for categorical data, and then interclass correlation coefficient for continuous data. So if the ratings are consistent across raters, then you have high inter-rater reliability. So that means your scoring system is standardized, it's easy, clear to understand, and then usually your manual or your instructions there is clear so the scorers understand what scores to put once they see or observe a certain behavior or symptom. So nag-agree silang tulo and a little bit ano lang, different siya. But if you compute it, they probably will have high reliability in terms or high interscorer reliability. So I have here the next discussion question, which is I have a scenario. Now, you're developing a new self-report MMBSS, mahal mo ba siya scale for couples. Now, my question is, which type or types of reliability would be most important to establish and why? Is it test retest? Is it alternate forms? Is it internal consistency? Is it interscorer reliability? Okay, so I want you to pause the video before you hearing my answer so that you know you have your own idea put as well. You can talk in the mirror. You can talk to yourself. What do you think? For me, okay, as I look at the question, internal consistency makes sense here. Okay, so coefficient alpha would tell us, ay, na wrong, coefficient alpha, okay, this one. Okay, coefficient alpha would tell us that the items are measuring the same construct together. Then test retest, in a way, it's a bit tricky if we're talking about love. Because love can change, sure. But love is relatively stable, diba? Let's presume it's relatively stable. It does not change. Example today kay love kaniya ugma kay di na din kaniya love. Diba? It's relatively stable ang love. So love can change, but it shouldn't fluctuate wildly, diba? Within a short period of time. So this could be, right? This could be one of the test pod. Now, ang kaning alternate forms, it could be optional but it's too advanced already. Why man? Because you're still developing a new self-report, meaning to say, wala pa nag-exist in a sense, no? Wala pa nag-exist, nag-make pa man kag new scale. So you only do alternate forms if you're trying to make another version of an existing scale that measures couples' love for each other. So, example, MMBSS, mahal mo ba siya scale, behavior version, meaning interscorer rater ang nida na magtanaw ang kuan sa when couples talk and then they rate or whatnot, diba? Or feelings version, for example. So when you get the two types of versions, you then check whether both forms yield similar scores. But if it's initial scale lang, meaning you're still developing it, it won't be that useful. Okay, it's not a priority. So what about interscorer? So interscorer in this case, because it is a self-report, here's the clue, it is a self-report measure, then you won't need interscorer reliability. Kung butang talang lang na projective test ni siya, then you would need this. If essay ni siya, you would need this. If behavioral observation ni siya na scale or checklist, you would need this. But again, it is a self-report scale, then you don't need interscorer reliability. Okay, we're almost done. Stay with me, okay? Don't go anywhere. So let's talk about the standard error of measurement. So unsa ni siyang standard error of measurement, or in short SEM? It estimates how much an individual score might vary if they took equivalent tests multiple times. So let's take a closer look. This is the formula of SEM. So it is the standard deviation times the square root of 1 minus r. Okay, so it just translates to telling us how much a person's score will bounce around if they took a lot of tests. Say, for example, this distribution here, It's just hypothetical, okay? So I want you to think now of this distribution here as the number of times the person took the test. So nagtook siya test ani, took test ani, took test, took test, took test, took test, took test, took test, and then it formed a like there's a distribution for it. So we'll go back to that idea after we tackle this one here. You understand why I let you thought of that. Okay, so we have here a scenario, no, si Bato, he is taking a reading ability test because he noticed na wala kay siya comprehension. And then let's say na the standard deviation of this test that Bato scored is 10. And ang reliability sa iyahang kuan ay sa iyang measure na gitake the reading ability test is 0.8. So what we will do first to get the SEM is to deal with the numbers in the parentheses. So 1 minus 0.8, 1 being part of the equation, and the 0.8 is the reliability coefficient for the test. That gives us 0.2. And then we square 0.2 and we get the number of 0.447. So we're done with this part here. So then we multiply it by the standard deviation. In this case, it was 10. So if you multiply it by 10, you get a calculator and calculate it with me, we will get the number, which is 4.47. Now we round it off to a whole number and then we get 4. So then we understand that SEM is 4. Now, Miss, what are we going to do with that number? So if we have an SEM of 4, this means that any given test score is likely to vary by about 4 points from the true score. Okay, the true score or the true reading ability score ni Bato. So nga nung mo vary man? Again, we've established that every measurement, there will be error. So that variation accounts for that error. Now, we can build confidence intervals around these values for it to have meaning. So, usan ang confidence interval? You'll understand that after tackling this one. So, the formula for confidence interval is this one here. Okay, so confidence interval is equals to the observed score plus minus the critical value times the SEM. So we're trying to make sense now of how SEM plays around with the data that we have. So critical value here, we understand what's observed score. Here we have, what's the observed score ni Bato? 50, right? And then the critical value, what is this one? We don't understand what's critical value. So what's any critical value? It's whatever is the Z score or T score is that corresponds to your confidence level. So if you want a confidence level that a certain range of score or a true score will fall a certain range, you want to be 95% confident, then you have to put there 1.96 or 2 for simplicity. Now, I want you to go back again to the distribution. Right, we notice here that 2SD equals to 95% of the population. Remember, this distribution now indicates the number of times that Bato took the test, just hypothetically, in a universe of possibilities, right? And so, if we want to be 95% confident that the score falls at that range, we need to multiply it by the SEM by that value. So far, so good. So it's clear no, ang formula. So let's go back to this one here. Now we have a score of 50 in the exam. And what is our upper and lower bound values? Talking about upper and lower bound is just talking about the range of possible scores where the true score falls in. Now, we have here the confidence interval equals to the observed score, which is 50, times the Z score, plus minus na siya ha, plus 2, here is the minus 2, times 4 equals to 58. Now we do it with negative as well, because remember we have the positive 2SD and the negative 2SD. So we do the negative for the lower bound. Okay, so our lower bound then is 50 minus 8 is 42. Now, in conclusion, or therefore, we can be 95% confident that Bato's true score lies within the range of 42 to 58. Here, I'll show you through the graph. Say this is right, the possible distribution of scores that Bato took in an exam. Okay, so we're sure that within these values lies the true score. Okay? So naadiri somewhat ang true score ni Bato. So, a lot of people usually misinterpret what confidence interval is. Even practitioners, even myself, right? So, unsa man gyud di ay ni ang confidence interval? What does this mean? So, CI, example, kaning 95%. Okay? Kaning 95% confidence interval, it's interpreted as the range of Bato's score, which will still fall between 42 to 58 in the future. So there are interpretation that is written that way. Now, that is incorrect. Unsay naka-incorrect ana niya? A confidence interval does not predict anything. No, it does not predict na, okay, for tomorrow, probably this score will fall around this range. For the next time that takes the test, it will fall around this range or this range or this range. It does not predict that. Okay? So, para unsa man jud ni siya kaning upper bound ug lower bound values. If this one here is like 42 and this one here is 58, para asa man ni siya mga upper ug lower bound values? O, 58 na ha, kasabot na mo. Okay, so in psychometric testing, confidence intervals, when based on the SEM, provide a more ethical and accurate way to interpret test scores. So they just remind us that the observed scores that we got from the reading ability test that Bato took is just an estimate and not an exact value. So that just acknowledges the uncertainty na we're not exactly sure if that's really the true score. It's plus minus some form of error. Okay, I hope that's clear. And it pushes us to be responsible with our assessment. Because again, whatever is our decision, it is influential in someone's life. Okay? So, CI in short is basically just saying, dili mi sure ha. Dili mi sure unsay exact number sa iyang reading ability score or sa reading ability score ni Bato. Okay, ano si Bato? Di mi sure. Pero we estimate na around this range, na around 42 to 58, lies his true score. I hope that's clear, no? I simplified this stuff for you. Okay, so we'll compare now the type of reliability estimates and we'll put them all together, the five reliability types. So we have the test retest, which catches time sampling errors. So again, this is best used for stable traits, or you want to measure if your measurement tool is reliable, or if your measurement tool that's measuring a stable trait and you want to check if it's a reliable tool. Okay, so next is the alternate forms or the parallel forms. Okay, it catches content sampling error. So it's good for makeup exams, retesting, achievement tests, etc. No? So the one that I mentioned a while ago as an example is like the type of test and the makeup test. Are they the same, or are both tests reliable? Because you're gonna correlate two forms. And then next we have the split half. So this split half also catches content sampling, but unlike this two, because it aims to reduce the time and the money it costs to establish reliability, its administration is only one. Okay, and then internal consistency is actually these three, but coefficient alpha as internal consistency looks at heterogeneity. So it's best for psychological skills. And usually, we already covered, right, the KR20 and then the Cronbach alpha. So you know what's KR20. You refresh ko na ba para asa ng KR20. It's for dichotomous items. And then the coefficient alpha is for multiple points, multiple data points, or multiple kanang kuan like Likert scale, like a rating scale, right? Yang administration also only one. And then interscorer is, well, the difference between the scorers' numbers. Like there are different judges and then they will rate a certain trait, and then you will then look at if they're consistent in the rating. So you would notice that each type is designed for different situations and catches different kinds of error. So that's why test manuals often report multiple types of reliability. So if we can in the next few sessions look at a test manual, we'll try to find out if they do report one, right? So you can find that in a test manual. So let's move now to interpreting reliability coefficients. Now, when you're evaluating a test, what counts as, when can you say it's good reliability? So we have here a rough guide. Okay, this one here. And then for 0.90 and above, we need this one for high stakes decisions. Okay, so for exams that could potentially influence someone's life, for example, the mental retardation test or school placement test, identifying whether or not you need to be placed in a school wherein you were given special education, di ba? You need to have 0.90 and above na mga reliability score. Between 0.80 and 0.89 is good, so it's acceptable for most educational uses. And then for 0.70, it's adequate for research. For example, if you have a survey there, so if you get 0.70 and up, that's still acceptable. And then if you get 0.70 and below, that's already something to be cautious of, okay? If below na siya. So anyway, when you're looking at it this way, context really matters. So an IQ, for example, determining special education placement, like I said a while ago, they need to be more reliable than just a simple classroom quiz. Needs your judgment as a professional. And also, there are different factors that affect our interpretation. For example, what's the purpose of the test? Is it for screening or is it for diagnosis? Because it's for diagnosis, you need to have very good reliability with that tool. Is it low stakes or high stakes? Where is it tested? Because, for example, if your scale is from a Western sample, you need to do a pilot testing again for your own samples. Filipino ba yung sample sa research? So you need to look at it because it could be reliable in one here. Oh, it could be reliable in one context, but it's not already reliable when it comes to your situation. And the next is restriction of range. So it is about the narrowness of the range, right? So if the range is narrow, then it has lower reliability value. Okay. So as for the dynamic and static traits as well, for example, dynamic traits includes mood and anxiety. So we expect the lower test retest. And then if it's static, we expect higher test retest na reliability. As for our final discussion, let me leave you a real ethical dilemma. So a child scores 72 on an IQ test with a reliability of 0.96 and an SEM of 3. Now, the observed score is 73 and above. Sorry, the observed score is 73, above siya sa cut-off score. But if you're using the 95% confidence interval, the true score could be anywhere from 67 to 79. Okay, 67 to 79. 79 na lagyo. Dool na sila nag-away. Nag-away lang. Okay, so now my question is, what should happen? Should this child receive services? Or like, how do you handle this uncertainty and high stakes decision? So there is no easy answer to this one because you need to marry theory and also your judgment, ethical implications. So I want you to think of the answer to this one. So let's look at our recap for the big ideas that we have today. First is that reliability equals consistency. So our formula there is from the classical test theory, which is there's a true score, and that the true score is derived from the observed score, which is the x here, and x it comprises of the true score plus the error. So every observed score contains the true score plus some form of measurement error. It could be a systematic error, could be a error that's unstable, weather condition, noise level, test administration, score interpretation. You get the point. Next is multiple types exist. Of what we mean by this is the reliability estimates. We have different types because we have different sources of error and we have different testing needs, testing situation, and different purposes for the measurement tools. So we use different types of reliability estimates. And with that regard, in connection to number 2, is that we need to match the method to our purpose. So for example, if we have a stable trait, then we can use the test retest. If we have a dynamic trait, for example, measuring babies, developmental milestones, right? They're very known for growing very fast in the blink of an eye. So a test retest might, make this test or the measuring tool produce a lower reliability coefficient than what is truly its reliability coefficient because of this changes or dynamic trait. And then we have the number 4, no? So SEM quantifies precision. So we use confidence intervals to interpret individual scores, especially for important decisions. We don't use confidence interval to predict where a score will land. No, we don't use it for prediction. It is for us to acknowledge that our observed score, the observed score that we get might not be accurate. I mean, it is not accurate. So there is an estimation of that in a form of range in a certain percentage of confidence interval. And then we have the number 5 is that context matters. So reliability is sample specific. and published values may not apply to your population. That's why, and this is very important, that if you get a Western centric tool that is normed in a Western sample, you need to redo it. You need to conduct pilot testing again if you're planning to let a Filipino sample answer that survey. Very important. And then lastly is that higher stakes equals higher standards. So life-changing decisions, high-stakes decisions, example, tools for diagnosis, tools that's used in clinics. It requires a reliability of 0.95 and above. Okay, so for research, we can use scales of 0.75 to 0.80 to 0.85. But for diagnostic tools, we need to have higher reliability, higher reliability scores. And that's it. Thank you so much. Before we wrap up, so review the terms. We have reliability, true score, observed score, error variance, reliability coefficient, SEM, confidence intervals. Okay, so next we will look at validity. So it's establishing whether we really did capture the trait that we want to capture, the mermaid. Okay, so that's it. Thank you, class. See you around.